Geometry, number 3. The exercise is about circles as always, and you go through all your motions, all of your theorems. There are 9, but don't forget there's lots of other stuff. Now, if you didn't read in the sum next to the sketch, you would have missed out on a lot of things. Next to the sketch, they said, in words, long sum, that F2 was equal to 180 minus 2x. So if you didn't read that, you didn't know that. Also, they told me that FC and FD are equal to each other. FC and FD are equal to each other, meaning what for me immediately? Isosceles triangle, meaning angles opposite equal, sides are equal, and what does that help me right from the start? C would be x, and D4. Please again, I just want to note, remember that the arcs of the circle don't make angles. That's not making an angle. It's between two lines. Those two lines make up the angle. So angle 4 there is equals to x. Okay, nobody asked me anything yet. I haven't written anything. First question though was, find the angle DEB. DEB would be this one over here. In other words, E1. Erase this. E1. Now, if you go for E1, now let's just do what Ma'am said right from the start. Some things are there automatically because of the isosceles triangle. Some of the angles of a triangle will automatically be. But the stuff that you don't know if you don't look for it are the 9 theorems. Now, I've got 2 circles here. But do I have the center of either one of them? Does it look like it could be? Looks can be deceiving. If they don't say it, it's not. So, there is no center in either one given to me, so I don't have line from the center is perpendicular to a chord. I don't have angle at the center twice the angle at the circumference. I don't have the semicircle. Number 4 is the bow tie. Not that I can see. You've got to look for it though, eh?
Yes.
Because sometimes it can be squished into a corner somewhere there in the circle. Corner of a circle doesn't exist, but anyway. Then we get to our theorems. Cyclic quads. 5 and 6. Are they cyclic quads? Yes. Yes, they are. Where? DEBC. DEBC. And what do you know about the angles of a cyclic quad?
Yes.
The opposite ones are supplementary. So this will be 180 minus. That's going to be this answer, if you had looked for it. Then if this is x, this would be 180 minus x. First question answered. Let's write it while we're there. So we're going to say what? Just that it's 180 minus x. Now you first got to say that C and D4 were both x for a reason. One reason. 2 reasons. Why? Sum of the angles of a triangle and angles of opposite equal sides. Whichever one you want to write first doesn't matter. Sum of the angles of a triangle and angles opposite equal sides. Not sides opposite equal angles, that's a different theorem. Once I have that C, then I can say, in other words, then E would be 180 minus x because opposite angles of a cyclic quad. Now maybe I should tell them where I found the quad since it's so lots of lines. You said EDCB, or whichever way you want to in order call it, BEDC, BCDE, whatever, it doesn't matter. Alright, second question asked to find the angle A. Where's angle A? Completely in the other circle. There's my angle A. So now we've got to start searching. Please remember, theorems we've only gone for 5 and 6. So cyclic quads, there are. Is there only one cyclic quad though? Where's the other one? ADF, B. Isn't this a cyclic quad? Say no. And why not?
Because
It's a half of one circle and another bit of another circle and a squish between the two. It's not a cyclic quad. Cyclic quad is in the same circle. We had D, E, B, C on those edges there. Are you with me? So in the top triangle, where's the cyclic quad?
A, B,
A, D, F, B.
B.
On the edges of that circle. So again, the A would be equal to F. 2 would be equal, yes, or we could have used F1 to find again. Supplementary. So I think maybe you would have said this is X because it's a straight line, and then found that, but then this would be, sorry, not X, 2X, I'm sorry. So it's 180 minus 2X, so this would be 2X, and this would be 180 minus 2X, because of opposite angles being supplementary again. You could have saved yourself one step if you immediately said exterior angle equals the opposite interior one. Do you see it?
Yes, ma'am.
Okay, so how would I write it? If I did what I did, I'd first say F1 is 2X because of a
Straight line.
and then A would be 180 minus 2X, and my reason? Opposite angles of a cyclic quad, and this time I'll say A, D, F, G would be equal. But if you left out that step, you would have had this as the exterior angle of that same cyclic quad. Prove to me that ED is parallel to BC. When you look at the sketch, how do I prove that lines are parallel?
You have
So
to.
that's grade 9, eh?
Yeah.
Alternate angles are equal if they are, the lines are parallel. Corresponding angles are equal if they are, the lines are parallel. Or co-interior angles are supplementary if they are, the lines are parallel. So how can I prove that these lines, I've made them orange, are parallel, and they are definitely not parallel on my sketch? Does that mean you call the invigilator and say there's a problem here?
No.
Sketches are not according to scale. If I say it's parallel,
Then it is.
then it's parallel, whether it looks like it or not. Okay? But how do I prove it? I need some angles.
D2 needs to be equal to
D. So this whole thing should be supplementary to that whole thing there. Okay? Or if you have these two together here, look at it. These two together should be 180 minus 2x, for instance. Are you with me? Or, again, those two must be supplementary. Depending on where's your transversal line. Two lines being transversal by line, then those will be alternate or co-interior, or over here as well. Okay, so I need some angles here to be able to get them. So maybe you're sitting and struggling and struggling and struggling. Don't struggle too long. Please don't forget that you still have triangles everywhere. I've already got that one and that one. So how much would the whole of be?
Oh, you need to.
Just X. How does that help me?
Tell me.
Either co-interior or then supplementary. Or if you wanted again to say, but then this is X because of a straight line. And then because of the sum of the angles of a triangle, this is X. And we see corresponding angles. And if you wanted to say co-interior, then you use the co-interior ones, it's fine. There was an alternate angles that I could have used here. Not that I see. Okay, that there's always another option.
Yeah.
So let's see, where did I start?
We started at say C.
B1 and 2, right? Or A, B, C was equal to X. How come? Interior angles of triangle, I think you should tell them. There's lots of stuff going on there.
Yeah.
And you might have seen something that the memo didn't have so far. So, big triangle interior angles, and then I'm seeing what? I haven't said it yet, so I better. T2 is X because of a straight line, that's how I used it. And therefore, if ABC and E2 are the same, is there a reason? There's not a reason, because I saw the one is x, the other one's x, so they've got to be the same. You want to say proven, it's fine, you don't have a reason for that. But because those angles are equal, the lines are going to be. But my reason, I'm not going to give you a mark for this, because this is what I asked. The reason is going to be the mark. Why are they parallel? Because you can say converse of corresponding angles, but it's actually just exactly a converse theorem. If I say the lines are parallel, then the corresponding angles will be equal. But if the corresponding angles are equal, the lines will be parallel. So if you just say corresponding angles are equal, it's fine. If you like to say converse of corresponding angles, perfect. Okay. So the next one, number 4, would be for the next time we do geometry.